So today we got something a little bit different. Instead of a commercial product or something that I made myself, it's something I did help with, but I most certainly didn't do the bulk of it. It's a model train. So obviously this is no ordinary model, this is one that you actually ride around on. So I have two locomotives here. They were built by my grandfather. I helped out a fair amount with the first one he made. This is the second one. We'll pull the first one out in a bit. So this one is a electric drive. It's got a, I believe, 20 horsepower Honda engine in it. So we'll start with underneath here. We've got 3 axle trucks on this unit, and as you can see, the motor drives the center axle, and then from the center axle we have separate chains running out to drive the other 2 axles. Each of them has proper bearings with grease nipples, but they're housed in these nice little grease boxes. Suspension is, I think, fairly obvious here as to how it works. We've got, frame with bearing boxes here, and the actual truck itself is sitting on these springs that come down to the suspension bars, and as you can see, they are actually split. They're independent, so that each axle can independently move up and down. The other side's the same. So basically each wheel is independent to move around on its own. So up here we got a couple, each side has its own permanent magnet DC motor that is mounted here on this little frame with the gear reduction. There's the chain that goes on down. Simple brake in there. I don't know how well that's going to show up, the brake caliper and that. And this whole frame that it's all mounted to, see if we can get a shot underneath, but it does pivot with the truck, so it always has the same orientation, so there is no strain on the chain from the chain being twisted. So up in here the brakes are air powered, as it also has an air horn. So we've got air compressor up in here with a simple magnetic clutch. We got an alternator, not very large. The battery is only used for starting, and then there's a few lights in that. But the main thing that is driven here, again, sorry about the lighting, I don't know how well that's going to turn up, but we do have a belt drive down to this shaft here that's reduced, and this is a DC aircraft generator. And so the drive system, it doesn't have electronic control for the speed. The speed is determined by changing the rheostat that is connected for the excitation for the field windings. In terms of directional control, the switching is done here through simple solenoids. And then up into the front we have the exact same setup again, but I'll just shove the camera in here blindly. So hopefully that gets another angle, but it's basically the exact same as the rear. Well, it's identical to the rear, other than it's spun 180 degrees. And we also have the horn up here. So there's a lot of empty space up inside, try and keep things cool. Around the front here we do have these nice grills. This one up on the top here is the body itself is drilled. These side grills do have actual holes inside. It's not just drilled out. That's a large access hole on that side, and I believe this side has a large, is it? Yeah, it looks like this side was round as well. Then again, underneath there was just the trucks. We've got a fuel tank here, fuel pump mounted up underneath, down low to try and help with heat. I know the other locomotive originally, the fuel pump was put up inside, but it didn't have a very long lifespan because of the heat, and it got moved. So with this one, keep it down and underneath where it can stay cool. These here are the air tanks. And small, I believe this was just a little toolbox. Unfortunately, I can't undo this latch right now with it sitting on this particular rail. So, well, actually, I don't think it would. Yeah, that would just clear normal rail. Normally, the rail is made out of 1/8 flat bar that stood up on edge. And my grandfather thought a lot about future maintenance and that. And so things like the engine there, there's little things like that. I don't know all the details on this locomotive, but there's he extended the drain for the engine oil to make it easier to do oil changes. On the other side here, you can see custom mount made up here for the compressor. The switch for the electric clutch, couple of regulators. I'm assuming he obviously had the brakes running at a certain at a lower pressure, and possibly one for the horn. I don't know. Maybe he was running the front and back at different pressures to change the braking distribution. I'm not completely sure. Like I said, I don't know all the details and all the ins and outs. I wasn't around as much for the construction of this locomotive. And then we've got the battery over here on this side. Alright, so the controls were pretty simple. I mean, you sat in a car behind it, which, by the way, instead of standard knuckle couplers, which although there is a pair, so that you can hook up to other people's cars, it does have the standard knuckle couplers. There's a simple link and pin system here, so they're not, you're not going to have issues with that. But yeah, the controls are really simple. I mean, you got engine throttle, horn, you've got a couple of meters here. Volt 1 seems to be stuck. It might be blown again. And there's a simple switch here for engaging the relays in forward and reverse direction. Voltmeter down there for the battery. And then here was your rheostat. So, simple valve here for the air brakes, key ignition, and the air compressor had a separate switch as an override for the clutch, so you can turn it off. And that's to help out with starting, because obviously you don't want to start the engine under load. So there's a light, the cooling fan, which I can't remember if I pointed out. It was up at the front, and the fuel pump had a separate switch as well. This keyed switch was just for starting. The other locomotive did have a switch with the on-off, and it just wound up a nightmare with the fuel pump and wound up destroying things, and just put the fuel pump on a separate switch. So I went with that right from the beginning, and then these that are unmarked, I believe, actually are blank. I guess I should mention that this light on the front here is actually a 12-volt emergency exit light. Just in case I hadn't mentioned, this here is where the cooling fan is mounted. It's up top, so this isn't just a dummy decorative piece. There actually is a fan in there. The exhaust out the top here, this is actually a dummy piece, but it does double as a nice handy rag holder. There's always rag stuffed in there. As for the engine, it's, let's see if we can get a shot in there. It's just a standard Honda engine. I believe this one was 20 horse. The muffler, however, if you come around the other side here, this muffler is custom built. So it was stainless with, I think there was a couple of baffles in there. It was nothing super spectacular, but the idea was that it exhausted out, of course, on the other side. Never cooperate and be where you're standing. So it exhausted out down the bottom here, so that way you didn't have exhaust spewing up into your face. So here's the first locomotive that he built. This one here is driven with an 18 horse, or it might be a 16 horse Briggs & Stratton, and it is hydraulically driven. So this time it's only a 2-axle truck instead of 4, but it's very, very similar in construction, and that we got the bearing blocks here, that can move up and down independently. Again, with bar and springs, but this time there's two sets of springs here on the one bar because there's only the two axles. So obviously you still need to distribute that out, and having them spaced out like that nicely, you still get that independence. So this wheel can actually go up and down independently from the wheel on the other side. I mean, they're obviously still connected by the axle, but they can still tip back and forth this way. And you've got, the front and rear axle. So this one can actually tip this way. This can go this way if it wants. So it can torque every which way. So it's extremely good at staying on the track. So next we'll go underneath and take a look at the underside. Alright, it's a little bit more cramped under here. Hard to get this all in, but again, we've got chain drive, so each axle has its own independent chain coming off of the motor. This time the hydraulic motor, because it's a lot smaller, is mounted right down inside of the truck. And then, I don't know how well this is going to show up, there is 3 hoses coming off, so you got your inlet and outlet on the pump. These ones are self-lubricated, so this here is a return drain hose that comes off from the oil that leaks through to the bearings for the lubrication. So, yeah, and I don't know how well any of this is going to show up, but homemade mounting brackets and tensioning system here to keep the chain, it doesn't have to be tight, but it's just snug enough. So these two lines here run up and over top of the fuel tank here, and one of them comes through and is connected to this motor here. The other one goes up to a valve, and the other line from here goes back in up to the valve, and we'll go take a look at that next. Just before we get in, this side was done a little bit differently. These side panels were made up and hinged, so they're made before the railing went on, so that's why the railing is not quite evenly spaced. Because in this case, instead of the panels lifting off, the railing actually comes undone, and you can just pop that open, and they are an open hinge like that, so they just come right off. Alright, hopefully this will show up okay. So here we've got the valve, this a spool valve, I believe. Sorry if I'm getting any of this wrong. Hydraulics is not not exactly my strong point, but you can see the lines here. So here's the AB ports, and they're just pipes running down through the main decking and attach onto the hydraulic hoses with a 90-degree elbow, obviously for strain relief. Now these teed elbows here and this line that comes up actually just loops around, and there is this ball valve right here. So right now this is closed, and that's how it would be for normal operation and when you park the thing. And now, as you can see, I can't move the locomotive. It will move forward and backwards just by the amount of mechanical slack that is in the system, in the chains. Now you're not going to be able to compress the oil, so those motors will also act as a pump. So they're attempting to pump the hydraulic fluid that's already in them back around and through this valve, which is closed. So in order to be able to push this locomotive when it's off, you need to be able to actually open the valve, and that's just a bypass, so now the oil can come around and circulate through from one end to the other. And the oil is provided to the valve, of course, from this hydraulic pump here. So we've got a large inlet hose that comes on in, and then the pipe out here is what exits and comes out to the valve. Now the valve, when you're not moving, is actually shut off, and the pressure builds up in that line very quickly, and this pump will then de-stroke itself and stop pumping even though it's spinning, and that's what this adjustment up here is for. If we can get in there, there we go. This guy right here. So that'll set your maximum pressure. Of course, the pressure won't be any higher than the flow is restricted by. So once again, we've got another line here for leakage oil that's used for lubrication when it comes off. This is the return for it. Now, there isn't enough room to have a radiator to cool everything, but the hottest oil that there's going to be is going to be this leakage oil. And it's a relatively small volume, so this other line comes up and is the oil return, and that oil actually goes through this cooler. So that makes a huge difference. So this is just a little radiator cooler here that that flows through. It's got an automotive fan in behind there. I don't know how that shows up. So that's cooled off before it goes back to tank. It's basically the whole front of the locomotive. So from right at the edge of the door here, this access panel, up until, you know, not tight into the nosing, but up front is all the tank, full width, and pretty much, yeah, the full height as well. And of course there is a filter here, so this is to filter the oil. So on this side of the tank we've got an old sight, you know, just a manual sight glass to check for fill level, along with a thermometer in there. And in case that shows up, yes, it is red, and it's not actually hydraulic fluid. I guess I shouldn't say that. This thing is actually filled with automatic transmission fluid. That's being used as a substitute for hydraulic fluid. And the reasoning behind that was that ATF actually has a higher breakdown temperature than hydraulic fluid does. So once again, with this we found that it was inadequate. The charging that was provided built into the motor, so very small external alternator here. And up on the other side is again a pump, air pump there with a electric clutch. And the one thing I've been finding really difficult to get a shot of, but there is a solenoid there, so a little electronic valve. And what that is that actually is a bypass, so that when the pump is starting out, because it's not de-stroked, there's no pressure, it provides a load on the motor. So by opening that up and allowing the oil to flow from the output of the motor directly back to the tank with no real resistance, just, you know, whatever resistance is provided by the small piping, that just unloads the mechanical load from the pump on the engine, so the engine has a chance of starting, and you're able to start it easier, you know, if at all. It's very difficult, you know, next to impossible to start it without that. And this one, the fuel tank, is a little bit different. It's got the air tanks mounted up and sandwiched in there, and as you can see, the fuel tank does go up and behind a bit. Again, this is fairly simple. This time it's cab back design for the body. So there's a little door here, and during the summertime they actually leave that door open just to increase airflow to the engine. As you can see, there's two large holes drilled down there as well. But on a hot summer's day, when you're pulling a lot of people, you get a lot of heat pouring out of there, and it's just nice to open it up and allow airflow, you know, maximum airflow through. So again, you know, we've got air horn set of gauges here. So we've got the oil temperature. I believe this one is mounted to the tank. The pressure, which you can kind of, you know, use that as a gauge for the for how hard you're working it. Actually, what's going on? That appears to be broken. I don't see a needle on it anymore. But yeah, I mean, the higher the pressure builds up, you know, the harder that it's working, the more resistance to flow there is. And you know, air pressure. And then a simple ammeter here for the alternator, just to make sure that it's still charging. It wasn't too fun when we had a couple of times there that we had some issues. Again, a key switch, throttle. So difference here is now we've got this hydraulic pump unload, the air compressor, and the cooling fan. And of course there's also lights, and I'm not really sure what's... oh, I believe this is for the starting. For the starter now. It was push button. There was a lot of problems with the keyed switch, and I know it went through... my grandfather went through a couple. Originally there was a keyed switch. And then the controls are dead simple. The spool valve allows you to reverse the direction of flow through it by reversing. So this has an indentation up at the top here. You bring it up, it actually wants to stop there. And that's the off position. So you have just simple forward and reverse. You know, you go a little bit, you give a bit of speed, you give her all the way, you got lots. And you know, you want to give her a little bit of throttle, but you know, you can run it, and you're better off not to be full throttle and running a little bit. You get going. Once you're full open on the valve, if you you need to, you know, you want some more speed, or you need some more power, you give the engine a bit more. There's some more revs. And then same thing, once you're back and stopped at the station, you know, to unload and reload on passengers, you can just idle her. And now the rolling stock I'm not going to take out, but there's a couple of cars. This one he built after I had moved away. So, I mean, I've seen it briefly, but I really like it. He was big into having, you know, tools and whatever you needed right there and having storage for it. So I mean, signal flag, and it was great. You could throw tools in there in case you had a breakdown, especially if you go to a club that has a large track. So we wound up building this with these swiveling chairs here to go behind the locomotive. So you got the engineer sitting on one side, obviously turn facing the locomotive, and then the idea was, rather than having a conductor sitting at the back of the train, which we found at the club that I used to go to with them, we found it was actually more effective to be sitting at the front facing backwards, so you were facing everyone, because then you could make eye contact. And that was the whole point, is you were right there. You could just turn around if there was an issue and say something. So you just sit here and, you know, look back. Prior to that, he had built this one here with a bench seat that you sort of straddle. As you can see, there's room on either side for your feet to go. And again, the seat just lifts up, and there was storage in there. You know, we used to put a bar. There's some blocks of wood. These locomotives are heavy, so if you do have a derailment, you definitely needed a pry bar and quite a few blocks of wood, you know, to act as levers and you know, to lift it up and sort of pivot it back into position. Now, this thing I can't really comment about at all. It's obviously just, you know, a rear truck, and it was designed to be suspended at the front end here off the locomotive. However, the first rolling stock that he built were these 6 gondola cars that would get stacked up, 3 on each side of the trailer. And these were fine. They have wooden seats, I believe, that are inside, simple plywood seats. So they got little cleats, they sit on there. The advantage is you can slide them up and forward and backward, depending on whether you have a small child or an adult, you know, and who needs more room, stuff like that. These are all aluminum for the body, so the angle iron here, angle on the side, aluminum plates. However, the actual frame underneath is welded at a square steel tubing. I don't know how well it's going to show up in the poor light under here. I don't think I'm getting it. Can't really see, it's too dark. And then the trucks are all machined out of steel. Okay, so I got it propped up, and you can kind of see the square tubing that runs down the middle there. Okay, and comes out over top of the truck, and then just runs down. But the rest of it, otherwise, is aluminum. The bottom and that. There is some steel angle iron back here, but like I said, it's just a steel frame that the aluminum was sitting on. So they're pretty much all aluminum except for, you know, a couple strength critical parts and all the wearing parts. These trucks here, they were very similar to casts that you can buy, but this is not cast. These are machined out of actual steel. So this is a little bit different of a design. The suspension is quite a bit different than the locomotive, so these aren't quite as independent. So you do have basically your wheels with your axle is all fixed. So this is not as flexible. However, you do have here your suspension is these springs with the bottom and this bottom plate sitting here on top of this, and this top one plate is what actually the car is sitting on. So if there's movement in the car, this is to, you know, and in the rail in the car, this allows them to move independently, is with the springs here. And you can kind of see this bracket that's attached. Let's see if we can get some light. And comes down these little tabs, and that is to keep the truck to limit the amount of rotation that it has. So it can't, if it comes off the rail, turn around sideways or, you know, 180 degrees or anything like that. Now these are attached with a system, simple little crow's nest system. So there's a little pivot in there, like a crow's nest pivot, with a large pin that comes down off of the car itself, and that comes down, and then there is a I can't remember if it's a pin. Yeah, it looks like it's a cotter pin in the bottom just to keep it from lifting up. So if you lift up on the car, the truck itself won't fall off. Now that is, if it shows up, there is an air cylinder right here, just sitting here unconnected. So these were set up for air brakes. Okay, so this is a simple air brake system with you know, air to apply the brakes, not to remove them. It didn't have a, you know, system like a real train did, but they were never hooked up. So here's the other cars. Again, this was really repetitive. They were all basically the same. The only special thing about the gondola cars was this seat that was made up for the conductor at the back. So it's got one of the wood seats screwed onto it, and then a second one went behind it. So you'd have two of the cleated wood seats basically underneath holding that for the conductor. So it was just a little bit more comfy when we had the conductor sitting at the back of the train. And then for stacking and unstacking the gondola cars, there's a simple jig. And there at the club that he went to, there was a frame that went with posts into the ground to with a simple lifting system to be able to lift the cars up, wheel them all out, drop the car you're working at down onto the tracks, unhook it, you raise this up, wheel the other cars back in, hook it up, drop it, or reverse, of course, for stacking. There's everything back into in the trailer, ready to go.